can you use the power of a quotient law to evaluate numerical expressions with whole number exponents? In the spring, Maya also picked strawberries on her family farm. She bought a new cube-shaped crate to hold the strawberries she picks. Write an expression using exponents to represent the volume of the crate. What is the volume in cubic meters? How is using exponents related to calculating the volume of a cube? One way to find the volume of the crate is to write the expression in expanded form. The volume is the length of one side cubed. The exponent indicates that 2/5 is multiplied 3 times. Multiply the numerators and denominators. Write the numerator and denominator using exponents. What is the simplified expression?
Select your answer.
Simplify the numerator and denominator. The volume of the crate is 8/125 cubic meters. Another way to find the volume of the crate is to use the power of a quotient law. The volume is the length of one side cubed. The power of a quotient law states that to find the power of a quotient, you find the power of the numerator and denominator individually. The volume of the crate is 2 to the power of 3 divided by 5 to the power of 3, or 8/125 cubic meters. Conversely, 2 to the power of 3 divided by 5 to the power of 3 can be expressed as the power of a quotient 2/5 to the power of 3.
Write equivalent expressions using the power of a quotient law and its converse.
So here we will 4/11, and they both are to the power of 2, and then we have 9/10 to the 4th power, and you just rewrite 9/10 to the 4th power. Simple as that.
Write an equivalent expression for 5 to the 8th power divided by 5 squared.
5 to the 8th power divided by 5 squared. Write the quotient as a fraction. Then you see how many times they're multiplied by in the expanded form. Then you see that 5/5 is equal to 1. So, those are, in a sense, canceled out. And then you're left with 6/5, which is 5 to the 6th power. And the quotient of powers law states that to divide two exponential expressions with the same base, you subtract the exponents. So 8 minus 2 equals 6.
Alonzo and Christopher created a scavenger hunt for their friends. The first clue sent their friends to a bus stop where they find this clue. Where will they find the next clue?
Step 1, evaluate 6 to the power of 1. That's from the clue here. And then it says you can use the converse of the quotient of powers law. 6 to the power of 1 is 6 to the 3rd power over 6 to the 2nd power. 6 times 6 times 6, 6 times 6, and then 2 of those cancel out, and you're left with 6 over 1 is equal to 6. So 6 to the power of 1 is the same as 6. So that's the identity exponent law. Now we're going to look at step 2, 6 to the power of 0. You can use a table and look for a pattern. As the exponent decreases by 1, each product is divided by 6. So 6 to the 4th power, 6 to the 3rd power, you divide by 6 each time. And so the zero exponent law states that a to the 0 power is equal to 1, assuming that a is not equal to 0. So a can't be 0. But as long as a is any number greater than 0, if it's to the first the power of 0, then it is going to equal 1, no matter what the number is. Evaluate the clue. So 6 to the power of 0, 6 plus that, that's 1 plus 1, 6. Then 1 plus 1 is 2, 6 times 2 is 12. So the friends will find the clue at 12th Main Street.
Write an equivalent expression for each expression using the laws of exponents.
So we have negative 11 to the power of 0, and that's going to equal 1. Then we have negative 2, the quantity of negative 2 to the 8th power divided by the quantity of negative 2 to the 2nd power. And that is going to be negative 2 to the 6th power. And then we have E, I'm just working my way down, 8 to the power of 7, or 8 to the power of 10 minus 3. You can write that as 8 to the power of, I didn't mean to do that, 8 to the power of 10 over, let's put a 0, 8 to the power of 10 over 8 to the power of 3. And then we have B, 7 to the 12th power divided by 7 to the power of 3. And so you would subtract the exponents and you get 7 to the power of 9. Then you have 1/2 to the power of 1. That equals, it doesn't equal 1. But when you have an exponent of 1, it just is an identity. So it equals the same number. Then you have negative 3, quantity of negative 3, well, not really, negative 3 to the power of 11, or negative 3, 15 minus 4. So that would just simply be negative 3 to the 15th power, negative 3 to the 4th power. That's it.